How to build a Blackgates Sweet Pea 5-inch gauge locomotive, part 34. After a visit to Blackgates Engineering in West Yorkshire, I returned to East Yorkshire with part of a driving truck, a full set of cast iron piston rings, some leaded bronze and a pack of 5BA hexagon head bolts. I show how to fit the piston rings. I bought this wonderful thing when I was at Blackgates Engineering. It's the top part of a 5-inch gauge railway wagon. There's no chassis, no wheels, just the top part, with this bit that lifts out. So what is it? I think it's a driving truck. The part that lifts out looks to be a water tank. What gave me the clue was when I looked inside it, it's quite rusty. I'll treat this to a bit of cure rust and then repaint it and it should be fine. So I have a water tank that needs a seat on the top of it, also with a generous space to hold some coal. I just need a suitable chassis for it to sit on. I'm going over to Blackgates Engineering again next week, so I'll see what they've got in the way of laser cut parts. This truck will really look the part behind a Sweet Pea when it's finished. I bought 4 1.5-inch outside diameter by 1/8 cast iron piston rings. I took one of the pistons from the Sweet Pea with me to Blackgates Engineering and I fitted 2 of the rings to it, with Phil saying, "If you break it, you buy it." But I didn't. I've fitted a few of these rings in my time. You have to be careful with them, but they're not quite as fragile as they look, and they do bend slightly. This is from a video I made a while ago about a visit to Blackgates Engineering. The next day I looked at the parts on the bench. Here are the 2 piston rings. I'm trying a test fit of one of the 5BA bolts, which I will be using to hold the saddle to the chassis. And the 1/8 of an inch diameter hole is a bit tight. I'm going to have to drill it out. You can buy a specialist tool called a piston ring compressor, but alas I do not have one of those, so instead I'm going to improvise. I'm using cable ties. These are the widest ones that I have, and the wider ones would do the job much better, but these will be fine. I compressed the first piston ring and pushed it into the cylinder, and then I carefully removed the cable tie and fitted a second one to the other piston ring. Initially I tried just one cable tie in the middle between the piston rings, but that didn't work. They're just not wide enough. But no matter, once I held the second piston ring tight using the cable tie, it slid into the cylinder very comfortably. At this stage I have to admit that I was a little bit worried about whether the cylinders were the right size, but believe me, these fits are perfect. I thoroughly oiled the piston rings before I fitted them into the cylinder. Then I fitted the gasket, followed by the cylinder cover, and here I'm tightening the bolts that hold it to the cylinder, being very careful not to over-tighten the bolts and snap them off. As I'm doing this job, I'm working out in my head the sequential order for reconstruction. After the piston rings are fitted, I could refit the wheels, but it's too early for that. There are quite a few jobs to do before I even think about fitting the wheels. For instance, the mechanical linkage from the cab to the cylinder drain taps. This needs a bit of thought, and I think I've come up with a very good idea on how to do it. Here I'm testing the piston in the cylinder, and I'm very pleased to announce that it works beautifully. Initially I used my thumb over one of the ports, but then I had a better idea. I used a piece of oily cardboard and a piece of wood to hold it in position. Then when I apply the air line to each of the ports, the piston rod moves back and forth with ease, and it's very powerful. And bear in mind that at each end of the cylinder underneath is a hole for the drain cocks, so it's working very well indeed. Time now to turn the chassis around and do the other side. First of all, releasing the bolts and spinning them out using a nut spinner. A very quick and simple job when the video is running at 400%. Even with the bolts removed, the cylinder cover was stuck to the cylinder, so I used my Barco spanner to persuade it to leave. Previously, I had fitted silicone O-rings to these pistons, but really, for a steam locomotive, I do prefer cast iron piston rings. If you take care, use plenty of lubrication and open the drain cocks after every run to remove any water present in the cylinders. They will last for years. Originally, when I bought this train wreck of an engine, It had 2 crosshead guide bars but only 1 motion bracket fitted. I think these guide bars are serviceable. Here I put a bolt in each end to check that the holes are in the same place on both of them, and they are, albeit a little tight, but I do think that's down to the size of the holes, not the fact that the holes are in the wrong place. But I'm just drilling out one end with my Proxxon motor tool. Here we go then, how to fit cast iron piston rings to a piston without breaking the rings. Cast iron is great in compression, but not so good the other way around, so you have to be very careful, just enough to get them over the piston itself and into the grooves. I recommend doing this job slowly and carefully, and I fitted the piston rings on this piston just like the other one, without event and without breaking any of them. I'll get back to the piston shortly. What I'm doing at the moment is drilling a hole in the flat part on top of the cylinder cover gland. This hole needs to be threaded 4BA to take a 4BA bolt which will hold one of the crosshead guide bars in place. The hole in the other cover is already drilled and threaded. Be very careful when doing this job. Just relax, don't put too much pressure on the tap. If it breaks off in the hole, your component is pretty much scrap. Reverse the direction of the tap frequently to clear the chippings, and be firm but gentle with it. After threading the hole, which was successful, I decided I would clean up the guide bars on a piece of wet dry sandpaper over the other side of the bench on my cast iron surface plate, which is very flat and very heavy. It worked out well really. The crosshead guide bars both look better now, and any marks will wear off in time once the engine's run. Here I'm using a Proxxon mini mott drill fitted with a wire brush to remove the rust from the end of the cylinder. Because this is an industrial engine and not a fancy express engine, I will be painting the cylinders. I finished the job using Scotch-Brite. The cylinder now has a suitable surface for the etch primer that I'll be using on it. Returning now to fitting the piston ring, I'm applying some oil in the cylinder and spreading it out inside the cylinder with my finger. If you do this, be careful, the edges of the cylinder are quite sharp, and bleeding profusely into the cylinder is definitely not recommended. I'm fitting the piston rings at this side differently to the other side. Instead of one, I'm using 2 cable ties, so both of the piston rings are held in a compressed state. All I did was tap the end of the piston rod with a piece of mahogany, and the piston slid very smoothly into the cylinder, dropping each of the cable ties in turn. It was definitely a better idea to use 2 cable ties rather than 1. Note to self, buy some thicker cable ties for future use. The last thing to do in this episode is to make sure that the crosshead guide bar fits into the hole that I've just drilled and threaded. It fits very well, and that concludes the episode. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.